functions and how to determine if your information is a function. So if you have a table, it can be vertical or horizontal, you are looking for the inputs. And remember that your inputs are your x's, your outputs are your y's, and you're looking to see, did my inputs repeat? So and it doesn't matter if your outputs repeat. This could be 12, this could be 13, this could also be 12, this could be 10 and 5. So it doesn't matter if your outputs repeat to determine if it's a function. It's your inputs, your x values. So you have to look at, did they repeat? In this case they did, so this is not a function. Okay, if I have something, let's say horizontal, and sometimes you have to determine whether the information is the input or the output. So if we said this was hours and this was miles, we don't say hours per mile, we say miles per hour. And remember, it's y over x. So if this is miles per hour, that means your x's are your hours. So I'm gonna go I can't go hour 1 and hour 1, that's just doesn't work. And you're driving or you're walking or you're going somewhere with miles. So if in the first hour I went 26 miles, second hour I went, let's say 32 miles, 48 miles, 12 miles, let's say I had to slow down because it's a low speed limit, and then I was able to speed up a little bit in hour 5, and maybe I'm repeating this. I can repeat, remember these are my y's, I can repeat my y's or my outputs. I cannot repeat my inputs. This is our x values. So I have to look at this. 1, 2, 3, 4, 5, nothing repeating, so this is a function. Okay, so you might have tables. You might have what's called a mapping diagram with the ovals, and remember that the thing on the left is the x, even if they don't label it, and the one on the right is the y. So they're gonna give you numbers. Just looking at the numbers doesn't mean this is a function because you don't see repeating. What you're looking for is the arrows. Let's say we had 12, 3, and 16. So if I have an arrow that goes from 2 to the 12, 3 to the 3, 5 to the 16, and then I have 4 that goes to the 3, this is okay because the thing that's repeating is the y. You're looking for whether there is more than one arrow coming off of your x's. So there's one arrow, one arrow, one arrow, one arrow. So this is a function. If you have one, remember these are x's and y's, so let's say we have 3, 4, and 5, we have 9 and 12. So if we have a 3 that goes to the 9 and a 3 that also goes to the 12, there's 2 arrows coming from the 3 of our input. So that's the same thing as having 3, 9, 3, 12, and so you have 2 of the same x value, so, or your input, and this is not a function. Okay, another way that you could have it are ordered pairs like I just did. So let's say we give you a list of ordered pairs. I'm looking at, remember that the x is on the left, think alphabetical order, x, y. So I'm looking at all the left ones. Do any repeat? No, this is a function. Now let's say I had 2, 3, 4, 2, 16, 4, and let's say this was again a 2 and a 7, and you remember you're looking for the x's on the left, and because I have this one and this one are the same number, this information is not a function. Okay, and we're also going to have graphs. So if you have the Sciency graph, let's say we made a scatter plot, these are our x values. Let's say we had a scatter plot. What I'm doing is the vertical line test. Literally take something vertical. Remember, that's up and down like a wall. And you can use your finger as well. Vertical, you're going across to every x. There's 1 point, 1 point, 1 point, 1 point. Oh, there's 2 in this particular x right here has 2 of the same thing. So they have this x has two different y's. So this is not a function. So if you had a graph where you had dots next to each other like this, this is a function because every one of these x's still only has one y, one dot, one dot, one dot. So this is a function because of the vertical line test. If you have 4-quadrant grid, and let's say you have your parabola, and it goes back up, these are angled, so they're gonna keep going over here, going over here into infinity. So looking at your x's, which are here, vertical line test still 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. 1 point everywhere. Same thing if your parabola goes down. Okay, so this is a function. If you have, actually let's make 4 quadrants. Let's say you had a vertical line. Do vertical line test. Oh, this 1x has all of these points on it, technically, to infinity. So every single one would have this. So you have, let's say this was a 4, 0, or 4, 0. You have your x is 4, 1, 4, 2. So you have repeating it. So if you have a vertical line, not a function. If you have a horizontal line, this is a function because you still have 1 point all the way across. So this is a yes for this one. And if you have the hyperbolas, if you have, basically they look like the parabolas, but they go sideways. So they still angle out. Sorry, I didn't angle that one out. They still angle out, but the problem is your vertical line test, every x, except for the vertex over here, has 2 points at every x, except for the vertex. So this would be a no. It's not a function. So you want to be able to determine whether you have a graph, whether you have a table, whether you have a mapping diagram, or whether you have ordered pairs. You're looking for the x's or the input. Sometimes instead of x, they put input and output. You're looking for the inputs. If they repeat, it's a no. If they don't repeat, it's a yes.